Hello everyone. So welcome to the final video of the Scikit-learn module. In this video, we'll talk about the random forest algorithm. And as usual, we'll first see the prerequisites, introduction, sample code, and then we'll discuss the advantages and disadvantages. So the prerequisites are Python, decision tree, and random forest. So decision tree because random forest algorithm is itself, you can say an expansion of decision tree because it uses n number of decision trees to finally give an output. So these are the prerequisites and good to know: pandas, numpy, scipy, and matplotlib. So introduction. So when you see what random forest is, the name in itself, it has forest, and we saw what decision tree is. So you can connect the dots and understand that maybe random forest is something which has a lot of decision trees. So it's basically what that sounds like, and you can see an example over here where we have a decision tree one, we have decision another decision tree and another decision tree. So there are n number of such trees. In this image there are three which you can see. So the first decision tree will give some kind of result for uh, a test data, and the second tree will give another kind of result. Now if you see, let's say if the green color dots are the test data is what you can consider, like there will be an attribute and the value will decide which branch. So that way if you map the green dots, that is an example of the testing data set or the testing data sample which we are trying. And so each and every tree will give its own output, like you saw in the decision tree in the previous video. So once all of these outputs are generated, what happens is there is a majority voting or an averaging in case it's regression. So let's say there are 10 trees in all. Out of them, let's say 8 trees are giving the output as yes and 2 trees are giving the output as no. So that way the final output of the random forest would be yes, because the majority is giving an output as yes. And based on the number of the equation, or like let's say 8 trees are giving, so the confidence will be higher if 6 trees are saying yes and if 4 trees are saying no. That way the confidence will be lower. So you can understand the confidence rate also. And for regression, again, each one will give its own numeric value, and the final output will be the average of all these. So you can see we get the final result over here. So random forest basically uses multiple decision trees, like I said, and it can be used for both classification as well as regression. So it generates a random subset of features which ensures low correlation among the decision trees. Now this is an important thing. If you take all the features at once and if you generate multiple trees out of it, all of those trees would basically be the same because you're using same features and same data set in each and every one. So there is no point of generating multiple trees if you're using the same number of features and the same number of rows, because all of them will be the same. Basically there will not be any difference. But what random forest does is it randomly selects n features, and then it forms a decision tree just based on those, let's say like 4 or 5 features out of let's say 17 or 20. So it takes these features randomly and then generates one tree. Now it will randomly select other few features, or it will randomly again select 4 or 5 features and again generate a tree, and this goes on till the number of trees we have set in our code. So this way many decision trees are formed and we get different outputs, and most of the times we get a very good accuracy using random forest. So it is one of the best. Now we'll go to the sample code. Before the sample code, we'll actually see the documentation. So on the official Scikit-learn website, you can just search random forest classifier and you can find this. So it is an ensemble method, which basically means that it takes into consideration the output of various, bases or various methods. So in this we are considering the output of various trees. That's why it's an ensemble method. And you can see the parameters over here. there's n estimators, which by default is 100, which is the number of trees in the forest. So you can set that value and you can customize your decision tree. If you do not set it, the default value is 100, and it can be changed from 10 to 100. So the criteria now, again, there are criteria through which the decision tree will be built. We talked about the various kinds of decision trees in the previous video. So entropy, Gini, and log loss. So by default, it will use Gini index, and these are the criterias like for the decision tree which we talked about earlier. So max depth, which is the maximum depth of any tree. So if a tree has a very, there's a lot of depth in the tree, so it'll take more time to form that, and it'll be a bigger tree. So you can also define the maximum depth and the minimum samples required, and this so on. And there's a lot of parameters actually, and you also have to decide the number of features it should take. Right, you can see n features, and there's a lot of things. So many of them are optional. Most of them are optional actually, and these help you to customize the random forest by yourself. Like over here you can see it's taking 1,000 samples and using 4 features at every tree, and we have also given max state. They have also given max state as max depth, I mean, as 2. So you can just go through it, and we'll just talk about the basic code as of now, and later on maybe if you're more interested you can research and see how it can be customized further. So let us begin with the code, and we'll continue in the same file which I'm using. So I'll just write random forest classifier. So we'll import the libraries first. Let's say I put a comment importing library, and will require numpy. Then we'll need matplotlib. And pandas. So now we'll import a data set, and for this I've actually uploaded a data set called as heart.csv. You can find it on Kaggle, as heart disease dataset. So I'll just show it to you. So right. So this is the heart disease dataset, and you can see there are a total of 14 columns, and you can download it from here from Kaggle. And I'll be using that. I've already uploaded it over here after downloading it from Kaggle, so I'll use that. So let's say data underscore set equals to pd.read underscore csv, and I'll just copy the path from here and I'll paste it. So let's just see. The first few rows. So you can see that there's various features like age, sex, there's CP, test BPS, cholesterol, maybe FBS, and most of the times if you're actually working on a real project, you will not be given the column names. So over here, based on the name of the data set and based on the already name given to the columns, you can somehow guess what it can be. So most in real life examples, if you're working with a company, most of the times they will remove these and you won't know exactly what the data set is about. So now we will extract our x and y. So for x we have to remove this column because this is our target column. So we'll take x as data underscore set dot drop, and we'll drop target, and axis will be 1. Now y equals to data underscore set, and we just need the column target. So that should do it. Yes, now we'll splitting. So we have to split it into train and test, just like every other, machine learning model that we tried, or algorithm. X train, X test, Y train, and Y test equals to. Okay, so before splitting, we have to import the library from Sklearn dot model underscore selection, import train, test, and split. And now we will write this train, test, and split x, y, and we'll take the test size underscore size as 0.2, 0.2, yeah, and random state, we'll keep it as 0. So let's see. Now we'll fit this data into decision tree without any pre-processing, and we'll see how it performs. Not decision tree, actually, in a random forest. So from Sklearn dot ensemble, import, we have to import a random forest classifier, and we'll take a new variable, random forest, and over here n estimators, we can take it as, let's say, 10, and we'll choose the criteria as entropy, and now we will fit our data, classifier dot fit x underscore train and y underscore train. Okay, so there's a typo over here. It should be classifier dot fit, and it's working. So we'll just predict y pred equals to classifier dot predict and x test. So our testing data will be predicted. We can also print and see y pred, but then we don't have a proper comparison to make, so we'll just plot the confusion matrix like we do every time from Sklearn dot metrics, import confusion matrix, and let's say cm equals to confusion matrix, and we have y test and y predicted. So we'll just print cm. So if you see, like I said, I've always mentioned that these two values should be highest as possible, and the lower these two values, the higher will be the accuracy. So these two values, which will be false positive and false negative, so they are 0. So that means the accuracy is 100% over here. I'll just show it directly from sklearn.metrics, import accuracy score. Yeah, import accuracy score and accuracy underscore score. So like you see, the accuracy over here is 1, that means 100%. So in this data set, without any pre-processing, we got 100% accuracy, which is the best. You cannot exceed accuracy of 100%. So that's how powerful random forest is, and it requires minimal pre-processing. It also does not is not sensitive to a higher number of features. In this we had 14 features or so, and we did not face any problem. So random forest also has no issues with noisy or missing data. So like you see over here, mainly what the reason for 100% accuracy was that the data set which we got was already clean and it did not have any noise. And also it was pretty I must say there was high information gain because we're using entropy. So since there was high information gain, and this was a pretty easy data set to build a model upon. However, if you try different models on the same data set, you might get a lesser accuracy, but random forest gave you 100%. Now in real world problems, when you are using you will most of the times, 99% of the times, you will have to do pre-processing, and there will be a lot of time taken into that. And again, in that scenario, you'll have to build your own model differently. You'll have to customize it. So in this we did not actually use matplotlib. We can plot it like last time, but it's not necessary. You can see that we have 100% accuracy over here. Now we'll go back to our PPT. So advantages. Now it does not require normalization or scaling of data. So like you saw, we did not even normalize, we did not do any kind of pre-processing, and we got a very good result. In fact, the best result possible. It's not sensitive to missing values. We actually did not check for missing values, and I can also create a mini project just using scikit-learn a library and different models and how they perform, and I can do that in the upcoming videos. But in this data set, I think there were no missing values, but even if there were, our model is not sensitive to missing values, so it reduces risk of overfitting. Now, overfitting happens when there are a lot of features in the data set, when the data set is very large, and the model, any other, most of the other models will have an issue of overfitting. But random forest does not have that issue because it only, even if there are 100 features, it will only take n number of features at one time to build a decision tree. That number is decided by us, by the developer, by the person who is training the model, and therefore it does not even consider the other features for that one specific tree. Now it builds many such trees by randomly choosing n number of features, and hence all the features are together, not used in one specific tree. So that's how it avoids the issue of overfitting, and there is no risk of overfitting even if the data set is large. uh, it requires less pre-processing. We did not do any pre-processing at all, and you can see that random forest still worked so good. It is efficient with large data sets and it has high accuracy. So we just saw that in our code. Disadvantages: it is time consuming. You did not realize it is time consuming because our data set was actually small, and there are many huge data sets which will take time to be fit into the random forest classifier. So it is more time consuming than others, and it requires more resources since it is parallelly building many trees using random features. So it is more complex also. Now when there was a decision tree, you could have easily mapped it down on a paper, and you could have written the notes, and you could have understood a path where the output is finally in front of you. So that was easy to map out and easy to understand, even using pen and paper. If the decision tree is provided to you and some kind of test data is given to you, you could map it out on your own. But when it is about random forest, there are n number of trees. That n can be 100, it can be 1,000. Now you cannot keep, by yourself on a pencil, on a pen, I mean on a paper using a pen. You cannot do that by yourself. Now there are thousands of trees, and you cannot individually find the prediction of each tree and then keep a count of all of them, and finally whichever has the highest count, give that as output. So even though you will understand the logic, you know what is going on, it is more complex to actually map it out by yourself without using programming. So that was the these are the three disadvantages, the main disadvantages. And that's it about random forest. And that's it from the Scikit-learn module. We mostly focused on the basics of many common machine learning models, and with those we also saw how pre-processing is done, or how metrics are used, and how Scikit-learn provides those, including data sets. So our main focus was around the models, and also how it's supported by these other features of Scikit-learn library. Now, once again, I have to tell you, Scikit-learn is not just limited or restricted to these, or what you just saw in the videos, or in these videos from the module. But there are a lot of things that you can explore by yourself. You can just research, you can find out, and you can also see the official documentation. You can go through it, and you will read and learn, and go into detail as and when required. So this was just an overview of the module, and that's it. So thank you for watching.